In this lesson, we are going to talk about right triangles. We're going to go back to acute angles A and B. And we're going to talk about finding sides and angles of right triangles. But this time, we are going to talk about exact values. In the past, for example, if we knew angle A was 50 degrees, we would plug it into our sine ratio. Actually, this would be the tan ratio. Apologize. Opposite over adjacent. The tan of angle A is equal to x over 10. Therefore, the tan of 50 is equal to x over 10. And on our calculator, we would type in x equals 10 times the tan of 50. And since tan of 50 is an irrational number, 10 times an irrational number is also irrational. It is not an exact length. It is not an exact value. So what we're going to do today is we're going to see there are some angles in which we do know that the tan, sine, and cosine of certain angles produce exact values, that we can use those exact values to calculate exact lengths. So the three angles that we're going to focus on that are acute are 30, 60, and 45, and we're going to look at that today. And so before we get into that, we do need to review our radical simplification. So when you're simplifying a radical, if you remember from grade 10, with root 24, we would look for the greatest perfect square that divides into 24. For example, 3 and 8 divide into 24, but I cannot take the square root of either of those, so those do not help me. But I do see that 4 divides into 24, so I break it down into 6 by 4. And since I can take the square root of 4, I take the square root of 4, and it becomes 2. Because 2 times 2 is 4. It is one of its two equal factors. And then I can rewrite root 24 as a mixed radical to root 6. The same as 32, just being careful if you can. Try to find the greatest perfect square that divides into it. So in other words, the 16 becomes, the square root of 16 becomes 4. And the 2 inside does not have a divisor that is a perfect square, therefore it is simplified. If it's already mixed, but this number has a square that divides into it, then you would just continue on. 25 divides into 75 3 times. The square root of 25 is 3, and 2 times 5 is 10. So making sure we remember how to simplify a radical. Now, let's get into our special triangles. The first one we're going to look at is a triangle that is a 45, 45, 90. In other words, it is an isosceles right triangle. And so what we're going to do to calculate these exact values is we're going to give it an arbitrary length of 1 for the two equal sides. And using the Pythagorean theorem, we can calculate that c equals the square root of 1 squared plus 1 squared, which is 2. So we now know the exact value of the hypotenuse. So the two legs are 1, 1, and the hypotenuse is root 2. Using this special triangle, we now know the exact value of sine 45. Sine 45 being opposite over hypotenuse, which is 1 over root 2. Cos 45, same thing. Opposite over adjacent over hypotenuse is 1 over root 2. So they are the same. And tan 45 is opposite over adjacent, which is just 1. So we now have exact values for those three. And so that's what that equals without having to be a decimal that we round off. We'll come back and we're going to show you various forms in a moment, but I'll just go down to the next triangle. It's a 30, 60, 90 triangle. And to figure out these sides, I'm going to start with an equilateral triangle, meaning all three sides are the same, so they're all 60. We're going to bisect the angle, drop a perpendicular down, and create two identical triangles. Since I bisected that angle, it's now 30. And I'm going to give each side an arbitrary length of 2 this time. It works nice because then if this full length is 2, half of it is 1. And we're going to focus on just our one right triangle here, which is a 30, 60, 90 triangle. So I drew it out down here again to focus on it. And so I have this being length 1, this hypotenuse being length 2, and this, so whatever you can tell across from the 30 is 1, the hypotenuse is 2, And so we just don't know this length. Well, we can use our Pythagorean theorem again to figure out the height of this triangle, which is the length of this leg. And so this time it's a leg, so our x squared equals, not the square root, but x squared equals 2 squared, the square of the hypotenuse minus the leg squared. X equals the square root of 4 minus 1, which is 3. So this is now root 3. So using this right triangle, we now have exact values for all our sine and cosine values and tangent values of a 30 angle and a 60-degree angle. So let's fill it in. Sine of 30, opposite over hypotenuse. Cos of 30, adjacent over hypotenuse. And tan of 30, opposite over adjacent. And here's our 60 up here. So the sine of 60, root 3 over 2. Our cos of 60, 1/2. Our tan of 60, root 3 over 1, which we just write as root 3. So we now have discovered all of the exact values for those trig ratios. Now, sometimes when we have a radical in the denominator, we like to rationalize the denominator because we don't like to have radicals in the denominator. So to rationalize a denominator, you just multiply by the radical in the denominator. And to make this an equivalent fraction, we do the same to the numerator, and we get root 2 times root 2 being root 4, or being just 2. We have rationalized the denominator. This is a fraction equivalent to this ratio, but with a rationalized denominator. Doing the same over here gives us root 3 over 3. So whenever we go back up to the top here, we can see whenever we have a radical in the denominator, we have equivalent forms, right? So that's the only one there. If we go all the way up here, oh yeah, there we go. So it becomes root 2 over 2. They are both the same. One is just a rationalized denominator. So moving down, how are we going to use these exact values? We're going to use these exact values now to find exact lengths. So this is the key. When you see exact values, we want to be not just typing it into our calculator, but calculating with those ratios. So whenever I see this, I like to redraw my two triangles. How do I redraw them? I take my 30, 60, 90. I know my 30 is the smaller angle. Directly across from it, opposite, is a 1. Hypotenuse is 2. Length is root 3. The other was 60. And then my 45, 45, 90, I just go 1, 1, root 2. By having a little sketch there, I find it very simple to just apply my SOHCAHTOA to those triangles to be able to solve this. So I just have my little sketch. I make it rather quickly, and then I go ahead and use my SOHCAHTOA rules. And so 45, since I'm using adjacent and hypotenuse, I'm using cos. The cosine of 45 degrees equals adjacent over hypotenuse. And I know that the cos of 45 is adjacent over, is 1 over root 2, using SOHCAHTOA up here. So I replace cos 45 with 1 over root 2. And now I just apply my equation solving. I cross multiply. And I always write, if it's 25 times root 2 or root 2 times 25, I always write the whole number first and then the radical. 25 root 2 is the length of x in exact values. Let's try that down here with the next one. So I'm using opposite over hypotenuse. That will be the sine of angle 60 is x over 30. Sine 60 is opposite over hypotenuse. It is root 3 over 2. I replace sine 60 with that. I just keep this the same. And now I cross multiply. I'll write that over here. 2 times x is equal to 30 times root 3. But now I have 2x, so I divide both sides by 2. And now I know what x is. 30 divided by 2 is 15 root 3. That is the exact value length of x. An estimated length would be 15 times root 3 on my calculator. And let's try one more. We have opposite over adjacent, so this time the tangent of 30 degrees is x over 14. The tan of 30, go back to our triangles, what is the tan of 30? It is opposite over adjacent. We can use our 1 over root 3, or we can use our root 3 over 3. I kind of like the root 3 over 3, so I'm going to use that one instead. And cross multiply. 3 times x equals 14 times root 3. And this is, you can now see why I like the root 3 over 3, because now when I divide both sides by a rational number 3, my answer is in simplified form. Since 3 does not divide into 14 evenly, we just leave it like that. Since root 3 is under radical and 3 is not a radical, you cannot simplify those. Okay, that cannot be simplified. Only a whole number with a whole number. You cannot simplify those ones. All right. There's word problems we can do. We have a pendulum arm of a metronome. It is 8 centimeters long, moves from start position of 45 to 135. So 45 to 135, 135 minus 45 gives us this angle of a good old 90 degrees. So that is a 90-degree angle. Therefore, and those are both the same length, 8 and 8, so we have a 45, 45, 90-degree angle. So now we know we can work in exact values because I've created one of the two special triangles. We want to know the horizontal distance. Now we know the actual distance it would take is along the curve, but we just want to know the horizontal distance it travels. So we want to know the hypotenuse of that right triangle. So we would use our x. We're going to use our 45 opposite over hypotenuse, or we could use cos, it doesn't matter. And now since I know sine 45, I'm going to replace sine 45. I don't have it here, so I'm going to quickly go, oh yeah, it's 1 root 2. Sine is opposite over hypotenuse. 1 over root 2, or in our simplified form, it looks like this. A rationalized form, sorry. And so now I can cross multiply. Oh, I didn't like that one. I think I prefer having it look like this. I kind of picked the one I like. That one works better for me. And so 1 times x equals 8 root 2. That is the length along the hypotenuse. No, I'm recording right now, buddy. Okay, I'm almost done. Here's our very last question. I'll just go through this quickly. A guy wire of 20 meters long supports a building at a 30-degree angle of elevation. Angle of elevation is always from the horizontal going up. The second one is 20 meters long at an angle of elevation of 60. And we want to know how much higher one is than the other. So that yellow distance right there is what we're trying to figure out. So if we take this complete distance here, which I will call y, and we find this distance here, which I will call x, and we take y subtract x, we will find the difference between the two. So I have a red triangle and I have a green triangle, so I'll just fill in the information over here. I know that, I don't know that. Same on the green. I know that, I don't know that. Let's use our special triangles to figure this out. So here we have opposite over hypotenuse. The sine of 60 equals y over 20. What is sine 60? Oh, I forget. Let's draw it quickly. There's my 30. 1, 2, root 3. Sine 60 is, there's my 60, opposite over hypotenuse. That's root 3 over 2, which is y over 20. Cross multiplying, we get 2y equals 20 root 3. Divide both sides by 2. We get 10 root 3. That is the height of y. So what is the height of x over here? Well, it's the same thing, except we have a 30-degree angle, so we get x over 20. 30 degrees is opposite over hypotenuse. That's 1/2. I don't need to cross multiply here because they're just equivalent fractions. X is just 10, right? So now I know that I can take my y minus my x to give me 10 root 3 minus 10. Since they are not like radicals, I cannot collect these terms and combine them, and that is my answer in exact value. If I wanted an estimated answer, I would change those to decimals and subtract, but in exact form, I would leave it there.